Welcome to my demonstration of my robotic arm project. For this project, I was seeing if I could control a virtual robotic arm utilising a Nintendo Switch joycon. To use this project, I decided I wanted to try and use the Unity game engine, as there's been a lot of developments and pushes in order for it to be used as a robotic platform. So I wanted to see what the capabilities of it could be. For the Nintendo Switch Joy-Con library in Unity, I utilised the Looking Glass and help from the Deku Nukem reverse engineering GitHub page. So it showed lots of various information showing how it could be connected to a computer. As the Looking Glass page also allowed the control of the Joy-Con. So as you can see, as I'm moving my Joy-Con in my hand right now, it's rotating this cube. Utilising this, I was able to program this robotic arm. So as I go into it, so as you can see, as I'm moving my arm, it's rotating the, lifting the, as my arm's going up and down, the robotic arm's going up and down, and as I rotate my wrist, the end effector is rotating. There are some buttons built into the Joy-Con, which I unfortunately was unable to properly integrate with my design, as it was a communication issue on the Bluetooth side, not the side of Unity or the Joy-Con. So as I've looked at the Unity engine due to its rather unique ability of design and hierarchy. So for example, each of these, so as this is one big object, you can assign different smaller scripts of code to various parts. So for example, controlling it using a keyboard utilises just a short bit of code, like a short bit of C# code like this, and can be attached multiple times to various points of the design. Likewise, for the control of the control of using the Joy-Con, it's a little bit more writing, but the same actions. So if as you can see on the script, the Joy-Con has a built-in gyroscope and accelerometer that allows built in internally, as compared to other devices like the Oculus Rift or the Nintendo Wii remote, where it requires a environment to be set up around the operator to capture the positions of the camera. These boast great accuracy, but the Joy-Con as well, with enough filtering, can attain the same accuracy levels. As it's all internal, this gives the Nintendo Switch Joy-Cons a great mobility in environments. So for example, I can move this all the way around and attain perfect grip. I can cover it completely with my hands in an attempt to block signal, and it still gives me the same accurate readings. So as this could be quite well to deploy in various environments that might have complications requiring a proper setup to utilise an Oculus Rift controller. So the movements of the Nintendo Switch Joy-Con uses some simple, so as you can see here, this is due to utilise a button to change the texture. As I mentioned, there was a communication issues in my computer which made the buttons not really responsive enough for my function. I've seen through other users that this is an issue on my end, not of the Nintendo Switch Joy-Con. Initially, I wanted to have the entire robotic arm controlled by the Joy-Con, and it still can, but I was required to change up my personal hardware to get it to work. Going back to but as you can see, it utilises the gyroscope and accelerometer values, and as from this bit, you can program the buttons and the joystick built in. So as the joystick movement, we could promote movement like this, or with the buttons to have the gripper opening and closing, demonstrated like this, or various buttons to allow advanced movement. So for example, one of the features I would like to have done is have one of the shoulder buttons be a movement block. So as you can see from it moving, it does hold some proper movement, but to properly access, like for example around here, inverse kinematics need to be done. So as you can see through here, this was just a button press to inhibit the rotation of this component independently compared to just the Joy-Cons movements. This provides more precision. I believe having a control scheme like this provides a lot of precision and a rather simple to use interface for operators. The reason I decided to use the Unity engine rather than ROS is as I was using a primarily Windows system. Utilising ROS using a virtual space I thought would give quite a lot of lag, and I wanted to see the ability of the Unity system. The Unity system can export a lot of this data, as for example, as you see, while I was running the application, the various pose data was actually being collected, and this can be exported to either into ROS to utilise into Gazebo or for a physical robotic arm. So this is the my robotic arm controlled by a Nintendo Switch Joy-Con. Thank you for watching.